It has been. Okay, so 9.1, we're talking about correlation. So you've kind of done some of this before, looking at linear regression, quadratic regression, taking a set of data and writing an equation for it. Okay, we're going to go a step further with it though. So we're going to do 9.1, 9.2, 9.3, and then you'll have a short, I'm going to call it a test and figure out how to make it more points. So that way it kind of bumps your grade up because it's a very easy section. It's mostly graphing calculator. Okay, so the graph of ordered pairs x, y is called a scatter plot. A scatter plot can be used to determine whether a linear correlation exists between two variables. Okay, so this first scatter plot is a negative. Maybe if this one's to write. Linear correlation. And notice it has a negative slope. The second one, as x increases, y tends to increase. So this is a positive linear correlation. The third one, they're kind of just all scattered everywhere. This is called no correlation. And then the fourth one is nonlinear correlation. Because that's a parabola, which would make it quadratic. We're only going to focus on linear. Okay. I went ahead and gave you the steps on how to make a scatter plot, including how to do it in your graphing calculator. So if you don't want to have to sit there and try to match up points on your homework and just type it in your calculator, you can. That's perfectly fine with me. Okay. All right. So what we're going to focus on today is correlation coefficient. Okay. So this is a measure of the strength and direction of a linear relationship between two variables. Okay. We're going to use the symbol lowercase r to represent the sample correlation coefficient. And then we have a formula. So the formula for r is r equals, and do a long fraction bar. And we have n times the summation, okay, so that big E, of x times y minus the quantity of the summation of x times the quantity of the summation of y. Okay. In the denominator, you're going to have two square roots. The first one is going to be n times the summation of x squared. So each of your x values squared minus the quantity of the summation of x squared. And then we're going to write the same thing, but instead of x's, we're going to use y's. So the square root of n times the summation of y squared minus the summation of y quantity squared. It looks really ugly, okay? But we're going to kind of simplify it. Where n is the number of pairs of data, okay? The population correlation coefficient is represented by what's called rho, which kind of looks like a curvy P. Okay. and this is red row. So the range of our correlation coefficients is from -1 to +1. Okay. The closer it is to 1 represents a strong positive linear correlation. The closer it is to -1 represents a strong negative linear correlation. And then when it's close to 0 or is 0, we call that no correlation. Okay, so we have some steps. So the first thing we're going to do is find the sum of x. So add up all your x values. Then we're going to find the sum of our y values. We're going to find the sum of the product of x and y. So when you do this, you're going to actually have to multiply x and y together first, then add them up. Then we're going to find the summation of x squared. So you're going to square your x's first. And then find that sum. Then we're going to find the summation of y squared. So square all your y's first and then add them up. And then we're going to plug into formula. For R. And then we're going to round to 3 decimal places. Okay. So there's your rounding for this unit. Okay. All righty. Some of you are still writing, so I'm going to let you write. Okay. I have faith that you guys can add. I have faith you can multiply. So most of these we're going to plug into our graphing calculator. So if you're given an example like this, use the data from the previous example, calculate the correlation coefficient R, and make a conclusion about the types of correlation. Okay, so you're given your X and your Y. We're going to type those into L1 and L2. So if you go to Stat and Edit, and then you're going to type all your X values into L1. And then type all your Y values into L2. And then remember how we found like our X bar, like we found our mean and everything? We're going to do that again. So once you have those typed in, go back to Stat, go over to Calc, but on yours, you have a number 2. Okay, mine doesn't have it on this, but if you do that on number 2, let me add these in real quick. Sorry, I forgot that this app doesn't have that. Okay, so if you do number 2, it says X list L1, Y list L2, and just keep hitting enter, and then it will spit out everything for you. Okay, it will give you your summation of x, which will be the very second thing on there. Which, what do you get? 88. And then it tells you that your summation of your x squared is what? 1,836. And then if you hit your down arrow, it'll give you your summation of y, 56.7. And then also your summation of y squared, which is 587.05. And if you keep scrolling down, it will also give you your summation of x times y. Okay, so these can all be found from your graphing calculator. Calc 2. Okay. Questions with that part? Okay, so there are 3 things from our formula we still need. Okay, so not from your graphing calculator, we need to find the summation of x quantity squared. Well, how are you going to find that? Easier than that. Do we know what the summation of x is? What? Squared. So we're going to do 88 squared. And we get 77.44. We also need to find the summation of y, quantity squared. So 587.05 squared, which is going to give you 344,627.7025. I highly recommend you do not round unless you absolutely have to. Oh, yeah, it helps if I look at the right spot. Sorry, I was looking at the y squared. Sorry. Thank you. Yeah. All right, so 56.7 squared. Whoa. How about 3,214.89? Sorry about that. And then the last thing we need for our formula is our n. How many data values are there, or ordered pairs? 7. Okay. Using your graphing calculator gets rid of probably about 10 to 15 minutes of work. Okay. If you don't have a graphing calculator, use Google Sheets. Let it do the math for you. Okay. All right. So now we're going to plug everything into our formula. So we have R equals. I'm going to rewrite our formula. So we have n times the summation of xy minus the summation of x times the summation of y divided by the square root of n summation of x squared minus the quantity of the summation of x squared times the square root of n times the summation of y squared minus the quantity of the summation of y squared. And then we're plugging in what we know. So R equals 7 times 435.6 minus 88 times 56.7 divided by, so our first square root, 7 times 1,836 minus, let's see, we already found it, so minus the 7,744. Okay. And then our next square root of 7 times our summation of y squared is 587.05 minus, we already found the summation of y quantity squared, 3,214.89. And then here's where it gets tricky. You have to plug that all in your calculator. Okay. Depending on what kind of calculator you have, if you have a newer one, okay, so the CE, use the fraction button. That's going to help you a lot. If you don't, parentheses are going to be your best friend. You're going to want a parenthesis around your numerator. And then you're going to need a parenthesis around your whole denominator. But then you also need to be careful when you do that square root. It's going to, make sure I tell you correctly. Depending on which one you have, if you have the 84 plus, you'll be fine. Okay. If you have an 83, make sure you close your parentheses after your square root to represent being out of the square root. Okay. If you have the 84, if you hit alpha y equals, it'll create that fraction for you. Okay. And that helps a lot. Okay, so if we plug this all in, you should get a number between -1 and +1. Okay. One way you can check to see if you have the right sign is look at the scatter plot, and you should have a negative slope. Okay, so our R, if we round this to 3 decimal places, is approximately -0.908. Okay. Questions with that? And let's see here. I'm trying to decide something. Okay, let's talk about this last part. So once you've calculated R, you can make it like you can use a hypothesis test to determine whether or not the data is significant. And that linear, you can write a linear function with it, which is what we're going to be doing tomorrow. Okay. So in order for a correlation coefficient to be significant, its absolute value must be close to 1. So if we take the absolute value of -0.908, we get positive 9.08. Is that close to 1? Yes. Okay. So then we compare it using a critical value that you can find in table 11. Okay. And for today, let's just focus on using that absolute value. Okay. I want you guys to focus on being able to find R before we look at finding our equation of the linear function. Okay. So I'm going to stop there for today.